is Chapter 10, Section 4, Perimeter and Area of Similar Figures. Your learning objective is that you will find the perimeters and areas of similar polygons. So here's a concept that we learned in a previous chapter that is coming back to us. So if you don't know what a similar polygon is, it is polygons that have congruent angles and proportional sides. So if you are trying to find a missing side, you use the scale factor or the side proportion from one side to the other to find a missing side. All right, so let's look at the problem. Make sure you write down the picture. So if I'm putting this in my notes, I would make sure I had the picture, and I would make sure that I had the ratio is 6/9, which is also equal to 2/3. I would also write the question, what is the ratio smaller to larger of the perimeters? When you guys are tackling these problems, you want to think of things in terms of, if I have a side length, what are my units? If I have a perimeter, what are my units? If I have an area, what are my units? You want to think of things in terms of area. Is there any difference in the units for a perimeter than there is for a side length? So if I am 9 meters here for my side length, what units is my perimeter going to be in? It's going to be in meters. So I'm just adding up all the sides. So from meter to meter, I know my scale factor or my side length ratio is going to be the same. So the perimeter of the ratios is the same as the ratio of the corresponding sides. So if I have, my ratio is 2/3. This is the small side, this is the small one to the big one. Then the ratio of the perimeters is going to be the same. It's also going to be 2:3. Small to big is 2:3. How hard was that? Not hard at all. We're done. So let's look at this. Let's look at our got it question. Two similar polygons have corresponding sides in the ratio 5:7. What is the ratio, larger to smaller, of the perimeter? It's going to be the same, except I'm going to switch these because it wants larger to smaller. So it's going to be 7/5, 7/5. That's the answer. So let's look at this problem number 2. The area of the smaller regular polygon is about 27.5 centimeters squared. What is the best approximation for the area of the larger regular pentagon? All right, so when we are comparing areas, the ratio of areas is equal to the ratio of sides squared. So when I'm finding the ratio of the areas, I want to make sure I take my side ratio and square it. And the way I remember this is check out our area units. Our area units are squared. Our side units are not squared. So the units tell the story. So if I'm going from sides to areas, I want to make sure I'm squaring it. So I'm going to take my side ratios from, what's the best part for the area of larger? So I'm going to go small over large. And the small one is 4, the large one is 10. So to find the ratio of the areas, I'm going to take 4 over 10. You guys okay with me simplifying this down one? Because that's the same as 2/5. And I'm going to square it. So my ratio of the areas is 4 over 25. So I know the area of my small guy, he's 27.5. So I'm going small area over large area. I have a nice little proportion. I'm going to cross multiply, solve for A. So I'm going to get 4 times A is equal to 25 times 27.5. Chug that in your. So that's 687.5. And then I solve for A by dividing by 4. And 687.5 divided by 4. So our answer is 171.875. And if I look between A, B, C, and D, C is the best approximation. 172. Got it? The scale factor of two similar parallelograms is 3/4. The area of the larger parallelogram is 96 square inches. What is the area of the smaller parallelogram? So if you look at the way this is set up, I got small on top, large on the bottom. You want to make note so that you can set up your areas correctly. So we know that the side length scale factor is equal to the area scale factor if it is squared. So my ratio of areas my area ratio is 3/4 squared, which when we simplify that out is 9/16. Then remember we got small on top, large on the bottom. We're going to say that 9/16, they want the area of the small one, so small is going to be our A. And the area of the large one is 96. All I have to do is solve this simple proportion, cross multiply, divide by 16. Equals 16 times A. So to solve for A, I divide by 16. A is equal to 864 divided by 16. And that's 54. And my units are square inches. All right. Problem number 3. Okay, so this is a word problem, so let me show you, if I were writing this word problem in my notes, how I would attack this. So the first thing I would do is write problem 3, applying area ratios on my paper. The second thing I would write down is 13 bushels of vegetables. And I would have that be summer 1. So I would go summer 1, harvested 13 bushels. And then I would go summer 2, because that's the next summer. The city will let them use a larger, similar plot of land. In the new plot, each dimension, so then I would write scale factor, is 2.5 times the original plot. How many bushels can the students expect to harvest next year? And then I would write definitely the question. How many bushels can the students expect to harvest next year? So what we're going to do is we're going to compare our area of summer 1 with the area of summer 2. So the first thing we'll do is we'll compare the dimension of summer 1 to the dimension of summer 2. So we're going to say, we know that the ratio is 1 to 2.5, as it tells us that it's 2.5 times the dimension of the original plot. So we're going to say the original plot is 1, and the next summer we get 2.5 times each dimension. So how do we convert that to area? Yeah, we square it. So all we have to do is square these guys, and we'll find the area of summer 1 compared to the area of summer 2. So then we just, I know what 1 squared is, and 2.5 squared is 6.25. So when they say how many bushels can the students expect, if I, with my original plot of land, I picked 13 bushels. With my new plot of land, I don't know how many I'm gonna pick, but it should be 6.25 times that is our scale factor. So we do the same thing, we cross multiply. And we have 6.25 times 13. It's 81.25 bushels. Do that one more time because I wasn't recording. So here we got triangles at the right are similar. What is the scale factor? And then what is the ratio of their perimeters, which are the same things. So if we take a squared over b squared, that's the area. The ratio of the areas is the ratio of the scale factor, or is the scale factor squared. So we're going to take 50 over 98. Then we're going to simplify it down to 25 over 49. Just divide both items by 2. Then if a squared is equal to 25, then a will be equal to 5. It's the square root of that. If b squared is equal to 49, then b is equal to 7. So our scale factor is 5 to 7. It's also the ratio of perimeters.